the end. I want you to write as much as you can for each video. What I'm going to do for the grade here, the person who does the most will set the points, and I'll compare everyone to that. Those of you who haven't done daily homeworks yet, here's a good chance to see what you need to do, and then I'll be happy to give these papers back to you and let you practice presenting them, and then we'll try to get that onto your Google slide. So here we go. Going to my Google slide for this class, I have the 7 videos now on a slide for you to watch. We've done 7 now. We're going to start with the first one right. So go ahead and take a look. Hopefully.
For a good example, I picked 2 points, which is -2, -1, and 3, 3. To find the domain, you have to go from left to right and to find the x's. So, since this is on the left, as you can see, the x is -2 because -1, -2. It's right there, so you plug it in right here. And then to the right is the 3, 3. And since 1, 2, 3, the x is going to be 3, so you plug it in right there. To find the range, you have to go bottom to top, and you have to find the y's. So for the bottom, the y is -1 because it's going down by 1. And so you plug it in right there, -1. And then for the top, it would be 3 because it's going up by 3. So you plug it in right there. For a bad example, if people get mixed up going right to left and they just get the whole problem wrong and the range top to bottom, you shouldn't do that. For a definition, domain is the set of input values of a function or relation, and range is the set of output values of a function or relationship. For the steps I did, for the first one, I defined where the dots are on the graph. And then for number 2, I defined the domain by going left to right and finding the x's, which was -2, 3. And then for number 3, I did find the range by going from bottom to top and finding y's, which is -1, 3. For an easier way, for interval notation, for domain, you always go left to right, and you always have to find the x. And for range, you always go top or bottom to top, and then you have to find the y's. For another easier way, domain is always left to right, and basically you read a sentence left to right, and you never read a sentence left or right to left, not like dogs love I. And then for range, you always go bottom to top, like filling a glass of water. It always starts at the bottom and then it fills up to the top, and never starts at the top and fills down at the bottom.
Alright, this is 11.6, increasing.
This is video number 2.
Decreasing max minimum interpolation. So for my plot, I have down here -2, 3, up here 1, 7, over here 4, 1, over here 5, 1, and then open dot 8, 4. My domain is boxed off -2, 8 curved, because for domain we're going left to right. So it would be from this point to my open point, and it's always the x-axis for domain. My range is boxed off 1, 7, boxed off because I'm going from the bottom point to my lowest point to my top point, which my lowest point is down here and my top point is up there, and it will always be on my y-axis. My increasing intern notation is boxed off -2, 1, boxed off, U, boxed off 5, 8, slash, not slash, curve, because for this one, we're going up by the, by how much we're going by, so it starts off from here to there, and that's how you get -2 and 1, and then from here to there, and that's how you get 5 and 8. My decreasing internotation is boxed off 1, 4, boxed off, because that's how much I'm going down from here to here. My internal where notations of change constant is boxed off 4, 5, which is right there on my flat surface. That's what it means. My max is 1, 7, boxed off 1, 7 boxed off, because my max would be the very top tip of like whatever's at the very top, which is my 1, 7, and then my minimum is boxed off 4, 5 boxed off, because these two are the least I have. My bad example is domain, is where you can commonly mess up on by adding like a boxed off instead of a curve, because it's an open dot. That's easy to fix. Or possibly another one is for domain, is doing, instead of going left to right, you go right to left, which would mess you up completely. My definition is domain, the set of input values of a function or relation. I got that for one of my classmates, so thank you to her. My first step is to find where all of your dots are on your graph, like we did up there. Number 2 is find the domain range by domain goes left to right, like I said, and then range goes bottom to top. Then number 3 is find your increasing internotation by going up to your slants. What I showed us there by going up where it's on all of our slants, which is boxed off -2, 1, U, boxed off 5, 8, curve. 4 is next find your decreasing internotations by going down your slant. What we basically similar to what we do there, except for that one big slant we go down by, which is boxed off 1, 4 boxed off. Number 5 is find the internotation where the no rate of change, consistency, and maximum and minimum. Basically, for this one, basically what we did up there, the flat surface, that's how we find it. The 4 and the 5 by the x-axis, and from our max, the highest point and the lowest point. What you need to know about the max always is it's going to be the highest point on the graph, and the minimum is always going to be the lowest point of the graph. And then my example is in the back. Also the same students helped me out on that too, but I just changed it up just a tiny bit. For increasing, I have charging my battery on my phone, so it's going up. And then decreasing is using my phone and killing the battery, which is going down. Domain is like it goes left to right, just like how we read and we look at stuff sometimes. And then my range is starting from the bottom and going up, so possibly going up the stairs or going up an escalator that's going up to like the 2nd floor. And so yeah, that is
for your patience. Here is video number 3.
So I did evaluate the given points for a function. For a good example, I picked this line, this point, and if it's given f of 1, basically this is an x, so you go on the x line to find 1, and you have to find the y. So you have to go all the way up until you find the line right there, and as you can see it's on 2, so you plug in 2. If you want to find 0, you go through 0, go up to find the line, and as you can see it's 1. Or -1, you go to -1, and as you can see it's right there, so it's 0. For a bad example is getting mixed up, so like saying if you are trying to find f1 and you go to the y number, you can get 0 and you could just get mixed up. Or if you go to f0, there you think it's -1. So do not get the x's and y's mixed up. For a definition, for evaluate is to find the value of an expression by substituting a number for each variable and simplifying by using order of operation. For the first step, you look at the problem and see what you have to find. For the second step, you go to that given point and find the line on that point to see what number goes through. And for 3, you write that number down. So for like an easier way to explain it, I did a chart. So evaluating the given points. So first you have to see what you have to find, which I did f parentheses 1 equals y. You have to go to that point right here and go all the way up to find the line that's going through, and then plug the number in, which is right there.
Video number 4.
So I did describing a relationship between two functions. For a good example, I picked g of x and f of x lines. So first you have to find out where these two lines intersect, which is this point right here, which would be 1, 2. Then you have to find out f of x greater than or equal to g of x, which is basically where is the f line on top of the g line. For an easier way is tilting your paper to where the g line is going straight across and finding where that line is going on top, which is this line right here. So you have to go from left to right, which would be -infinity, 1, because that's where it ends. You have to do the same for g, which is finding where the g is on top of the f. So I turn my paper to where the line is across and see which one is on top, which is that one. So it would be going left to right. So that would be 1, infinity. So if you are trying to find like this, f2 plus g 0. So first you go to 2 and go up where the f line is, and that would be 1. Then you go to 0 and find the g line, and what point that was 1. So that would equal 2. For a bad example is getting those mixed up. So if you go to 2 and you're trying to find 1, and you go up to the g line, you would get 3. If you go to the 0 and you have to find the g line, and you go up to the f line, you would get 3 and you would get 6. So do not get the lines mixed up. For a definition for an intersection is a point where two lines or streets cross. For steps, 1 is look at the two lines on the graph. 2, find the point that the two lines intersect. 3, find where the f
is on top of the G line, do the same to find the G line. 4, find the two terms on the graph like f of 2 and g of 0, and find the number on that term that goes with the line. For an easier way is like the intersection line on a graph is like a road. So basically, if one road is going this way and the other one's going that way, it's going to intersect right here, which is basically there would be a stop sign and everything. So for the relationship between two functions, first you have to do the f of x equals g of x, which is the intersection. Then you have to go f of x greater or equal to g of x, and the g of x greater than or equal to f of x. Then you have to do the f of x plus gx equals whatever number.
Here is number 5.
So I did have to tell if information given represents a function or not. For a good example, I picked 1, 6, 2, 7, 3, 8, and 4, 9. So a function is each input has a single output. So 1 has a single output of 6, 2 has a single output of 7, 3 has output of 8, and 4 has output of 9. So that would be a function. This one would not be a function because 2 that's an input, has 2 outputs. So 2 has an output of 8 and 4. For a bad example is saying like, or looking at the y's instead of the x's. So you can see that the y's has 2 1s and you think it's not a function. So like you would say 1 has an output of 1 and 1 has an output of 4. So you would say it's not a function. But it's wrong because it is a function, because 1 has an output of 1, 2 has an output of 6, and 3 has an output of 7, and 4 has an output of 1. For a function is a special relationship where each input has a single output. For steps, number 1, you look at the points, charts, or graphs. Second is look at the x numbers to find out if it's a function or not. 3 is write function or not function. For an easier way, or function or not, so a function is each input has one output. So 1 has an output of 6, 2 has an output of 9, 3 has an output of 7, and 4 has an output of 8. For not a function is an input that has more than one output. So 1 has an output of 4, 2 has an output of 8, 3 has an output of 9, and 1 has an output of 10. So 1 has an output of 4 and 10.
Here is video number 6.
The algebraic points, and I didn't graph them. I just decided to use the algebra version. So this was gx equal to 3x plus 1 for one of the lines. Fx is equal to f plus 3. This is a good example. And then what you would do, you take this, you put them together, then you just use your algebra method and you subtract on one side, you subtract to get the x's on one side and then just the regular numbers on the other side, and then I got 1. And then you plug it into one of these equations, just look at those ones, and then like this, it's multiplied and you put it in brackets, 3 times 1, 1 plus 1, and then that's equal to 4, and the points are 1, 4. This is where they cross. And then for my bad example, it's basically the same thing, except some people just like to stop right here, which you don't want to do because otherwise it's not going to be able to get you anywhere. That's only basically finding one point, but that could be quite a few points on the graph if you actually tried to like mix them with the y-axis or whatever. And the steps are combine both lines into an equation, both of these lines, and then you put them in like that. Solve, use like a seesaw method. So you just basically use this, but you have to make sure if you subtract on one side, you subtract on the other, just like with the x's. And then don't forget to plug in the answer to the to one of the lines to find where they cross, like this. And then yeah, like I was saying, an easier way to think of it would be, or an easier way to do this was you think of these as lines. It's just mx plus b, and then this goes up. This starts at 3 on the y-axis, goes up 1, goes up 1, goes up 1, and then starts at 3 on the x-axis. 1 on the y-axis, goes up 3, 3 over 1, 3 over 1, up 3 over 1, up 3 over 1. And a definition, I did algebra. This is a part of mathematics, in which letters and other general symbols are used to represent numbers and quantities in formula and equations. And yeah.
Here is video number 7. Sorry that it was out of order, but here is the last of the videos.
Okay, so I have the infinitives homework. I have a good example here. So the domain would be -2, and then the infinitive sign because it's going straight up, the arrow, and then it's a positive because it's on top of the x-axis going straight up. So that would be the interval notation. The set notation would be -2 is greater than or equal to x greater than or equal to infinitive. Alright, and the range would be -2 is, and then the infinite symbol right there with the round bracket. The infinite logo will always have the round brackets because there's no way to measure the number. And then here we have it would be y instead of x because it's on the y-axis. Be -2 is greater than or equals to x greater than or equals to negative or infinitive. And then I have the bad example here, and the reason why this is all bad right away is because there's no numbers here, or no infinite number which would show this arrow right here. So there's no number that would show that right there, which would make this all wrong. And the definition, a notation for representing an interval as a pair of numbers. I have the steps: locate the points, find both domain and range, check for the arrow, meaning it's an infinitive. Instead of placing a number for the arrow, place an infinite symbol. If the symbol is below the x-axis, it's a negative. If the symbol is above the positive, set an interval notation using the symbol. And then going back here, we have the other way of showing it. We have infinite notation, domain, range, left to right, bottom to right. Then to sum this up, it's if the arrow is going up, it's going up and it's on the top of the x-axis, it's going to be a positive. If it's going down and below the x-axis, it's going to be a negative.
Good job to all those who let me watch those. Big extra credit. I appreciate it. Hopefully this will help. Good luck.